Assalamualaikum warahmatullahi wabarakatuh. And how are you, my students? I hope you are doing well there, yeah, and good, healthy with your family. Today is our uh, week 12, right? Since I'm talking to you about scheduling. So scheduling is the continuity of our previous studies, material requirement planning. But scheduling is one of the most important in industry actually. Right? What is scheduling in your mind? Okay. Scheduling is concerned about establishing the timing of the use of equipment, facilities, and human activities in organization. Yeah. All right. And also effective scheduling can support cost saving for industry and also of course increase in productivity. Why? Because if you have a good scheduling, the process for doing the production is on time, so it will reduce the cost for waiting. Time is very important in industry, so it will increase the productivity. For scheduling context, scheduling is concerned by multiple system designs decisions. Of course, the first, we need to identify the system capacity in our industry. So, and also product and service that we want to design, equipment selections, worker selection and training, because the worker, skills worker and unskilled worker will be different, will result difference for our industry, and also the aggregate planning and master scheduling. Okay, this is two type difference between manufacturing and service. Okay, you can see here the difference is when in the pink color, yeah, aggregate planning. So service also have aggregate planning, but for manufacturing we need to consider clearly about the material requirement planning, but for service is about monthly or weekly schedule. And manufacturing normally use shop floor schedules, but for service we'll focus on daily schedule. Right, high volume system. Okay, for example, the example I will share to you here. So the underlink, there are a lot of example to use schedule. This is only the theory that I will explain to you. The schedule I will give you the different link to explain because the explanation is more clear there. Okay, now is high volume system. First, what we should concern is about the full system. High volume system, the standardized equipment and activities. And if the volume of production in our industry is high, so we need to also consider the equipment can fulfill the activities to produce the product with the high volume, and also we need to increase the activity. Flow system scheduling, this is scheduling for flow system. The goal is to achieve a smooth rate of flow of goods or customers through the system in order to get high utilizations of labor and equipment. So we have a good scheduling for the flow system for our scheduling. It's good, so we will get a high utilizations of our labor and equipment. Okay, the high volume schedulings. This is the difficulties of a high volume. View flow system are entirely dedicated to a single product or service. Okay, each product change requires slightly different input of part. This is the some issues in scheduling, yeah, that we need to clearly identify for scheduling. Mostly the issues is about this one. slightly different material. Different material also will make issues for scheduling, and slightly different processing requirements that must be scheduled into the line. Okay, and then need to avoid excessive inventory build up. So inventory, we need to clearly the inventory is not too much in our inventory. If the inventory is too much, it will also problem for scheduling. Disruptions may result less than desired output. High volume success factor. So this one that make the success for volume system. Okay, the volume factor often dictates the success of high volume system. First is process and product design. Okay, process and product design. We need to identify clearly about the process and the product design system. Okay, starting from the raw material, yeah, not starting from raw material, for the requirement, specific requirement for product design, and also how to process the design, yeah, and then after that, after the ends of the product. And then the second is the preventive maintenance. Of course, for the machines working, for example, 24-hour, need considered to make a maintenance for our machine. For example, 3 months time, one time for do maintenance for 3 months, and then we do 3 months. So we need to consider the preventive maintenance when we want to do maintenance. Rapid repair when breakdowns occur. We need to make the machine, if the one's machine's problem, we need to make it a change. We need to repair it fastly. For example, one system problem, so we need to make it faster to get a good scheduling process. And optimal product mix, minimizations of quality problem. Okay, we need to reduce the problem in the system, and also reliability and timing of supplies. About the material, for example, the material come late, so it will problem for our schedule. But if the timing for supply is good, the material come good, so it will make the schedulings better. Okay, next. Intermediate volume system. So in this intermediate volume system, we need to consider the output fall between the standardized type output of high volume system and the made to order output of job shop. And then output rates are insufficient to warrant continuous production. Rather, it is more economical to produce intermittently. And then work centers periodically shift from one product to another. Okay, this is the formula, yeah, for 3 basic issues for run, size of job, the timing of job, and the sequence in which job will be produced. Intermediate volume system. This is important consideration to set up costs. Yeah, to identify the setup cost. Usage is not always as smooth as assumed in the economic lot size model. Alternative scheduling approach. This is based on production's master schedules developed from customer order and forecast demand. So the alternative approach, we need to identify the customer order, and also we need to identify or make a calculation for forecast the demand. Low volume system. This is about job shop scheduling. This is scheduling for low volume system with many variants in requirement. MTO, make to order product. This is also for processing requirement, material requirement, processing sequence and step. So starting from high volume, intermediate volume, and it is low volume system. And also complex scheduling environment. It is impossible to establish firm schedules until actual job orders are received. Loading. So the loading is the assignment of job to processing center. It can be, we can use a Gantt chart. Yeah, Gantt chart. This is usual to add for loading and scheduling purpose. Actually, Gantt chart is to identify the time. Yeah, purpose of the Gantt chart is to organize and visually display the actual intended use of resources in time framework. Like your maybe later for your PSM, you need to have a Gantt chart or framework. Managers may use the chart for trial and error schedule development to get an idea of what different arrangement. Okay, this is example of load chart or Gantt chart. You can see in the work center 1. This is in the Monday job 3. So we need to give also for the Tuesday for work center. Yeah, work center 1. So in work center 2, Tuesday, this one the work center 3, job 1 and job 10. Yeah, this is you can see here. Yeah, this is schedule chart. Schedule chart is a Gantt chart that show the order or job in progress and whether they are scheduled. They are on schedule. They are on schedule. Sorry, they are on schedule. Okay, you can see here we have a stage drawing, side trees, final. This one is the week one after the registration one will be. Okay, loading approach. This kind to in scheduling there are two kind of approach for infinite loading. We don't consider the loading. Finite loading, we consider the loading. So you can see here infinite loading, even overloading, yeah, overload. This one is loading. This overloading in week 2, week 6, overloading. So we still consider it. But for finite loading, more than this one, more than our capacity, so we don't consider it. Yeah, but for lower loading, so we still consider it. Scheduling approach. Two kinds of the scheduling approach. First is about forward scheduling ahead from some point in time. Okay. Okay, forward scheduling. For forward scheduling, we consider ahead from some point in the time. Use when the question is how long will it take to complete this job. So we just consider from others, but for backward, the schedule backwards from some due date. This is used when the question is when it's the latest the job can be started and still be complete on time. Okay, in our module, yeah, it's very clear. Managing workflow, yeah, input for output control. This is managing workflow and queues at work center without input-output control. If the demand exceeds processing capacity and work center overload is created. If arrives more slowly than a work center can handle, work center underutilization result. The goal of this input-output control is to strike a balance between input and output rates in order to minimize queues and maximize utilization. Okay, input and output. If the output and input is output per input is productivity, right? Still consider it. Okay, you can see here input output chart. Plan is 100. The actual is 120. So deviation, the difference between this one is 220, and then cumulative deviation is the cumulative between this one. Yeah. For example, planet 100. This one is 99, 95. So the rest is 5 minus 5. So we have cumulative here. So we still have 15 until this one. For the output, it's the same thing. Yeah. Plan 100, 110, 110. So the one 0, 110, 105. So this one is 5, 5. This cumulative. Yeah. 5 minus 5 minus 5, 10 minus 10 minus minus 10 plus 1, so minus 9, and so forth. Assignment model. Okay, so assignment model is a linear programming model for optional design as assignment of tasks and resources. And also we have a Hungarian method. Method assigns job by one for one matching to identify the lowest cost solution. I give the example for this later in the link. Yeah, I will give the link. This one is material, and then the process also I will give the example by example. Yeah, first is row reduction. Row reduction ini subtract the smallest number in each row from every number in the row. Okay, assignments for row reduction is like this. Yeah, row reduction. Here you can see we have this is the name of food. This is food 1, 2, and 3. Bean, peach, tomato. Correct. And from this one, we need to select. Okay, we want to row reduction first. We need to select the smallest number here. What is the smallest number? 5, right? So when you select 5, so we just reduce all this row using 5. For example, here, 10 minus 5 is 5, 5 minus 5 is 0, 6 minus 1, 6 minus 5 is 1, 10 minus 5 is 5, right? In the second row, 2, to just reduce to 6 minus 2, this one is 0, this one is 4 minus 2, okay, this one, and after that you get all the thing. And then you column reduction. Column reduction, you need to select the based on this. Yeah, based on this result, the smallest is from first row is 2, so you just reduce 5 minus 2, 3, 4 minus 2, 2, 2 minus 2, 0, and 5 minus 2 is 3, and we do it all for all. Yeah, okay, and then we try to cover our 0. Yeah, from here we just make a line, this one, and will be from B. Okay, sorry, this is the class is the continuous. Sorry. So based on this calculation, okay, this the calculation before, right? And we need to cover 0 again. This one 0. We need to make a line like this, and then beans, okay, is cooker 2 in the cooker 2, peach in the cooker 1, town is in the 4, The con is local 3. Okay, so we just complete for all 6 hours using this previous data. The previous data we put it based on this calculation, so we just put it based on the value here. Okay, I will put the example in the link. Yeah, don't worry. This one just to show you. Okay, let's continue to the next slide. Okay, let's we go to the next sequencing. Is determining the order in which all works will centrally be processed. And priority rule, this is a simple heuristic used to select order in which will be processed. The rules generally assume that job setup, cost, and time are independent of processing sequence. Job time needed for the job. Okay, this is a priority rule. We have the book in our module. Yeah, in our module, page number. Okay, starting page number 151. Yeah. First come, first serve. FTFS. SPT short first processing time. EDD is due date. Yeah. Critical ratio, select promotion, and also as emergency. Process emergency thing. Yeah. Okay, priority rules assumption. The set of job is known. No new order arrive after processing begin, and no job are cancelled. So in this assumption, if we already start the job, so we cannot cancel. We just need to calculate, and we need to consider, and we want to know. I mean, there is no new order come after we calculate. Yeah, processing begin cannot disturb the process. Setup is independent of processing time. Setup is deterministic. There will be no interruptions in processing such as machine break or accident. So you can open example page 153 in our module. Okay, sequence performance metric is one performance metric, job flow, time, job lateness, mix, and average number of job. We can open our module also. This is sequencing. Jones rule. Yeah, this is a technique for minimizing completion time or to be processed on two machines or at two work machines or work center. This is to minimize total idle time and several conditions satisfied. Okay, this is Johnson's rule conditions. Job time must be known and constant for each job at work center. Job time must be independent sequence. Job must follow two-step sequence. Job priorities cannot use. All unit must be complete at the first work center before moving to the second work center. I will give the example the process of this here. And then scheduling difficulties. Okay, I think the first is already explained. This is a variability in time, processing time, interruptions, and change in the setup job. Method for identifying optimal schedules. So until now, there is no identifying optimal schedule. Scheduling is not like science because there is many problem will appear in the real conditions. Yeah. So it is not. It is an ongoing task for a manager. The manager need to consider the situations in the company when they want to do scheduling. Okay, minimize scheduling difficulties. First, you need to set a realistic date. So don't to be more confident for the date. Yeah, We need to be relevant with our capacity, like our resources, human resources, our machine, and so forth. Focus on bottleneck operation. So if we already identify the bottleneck, we need to reduce the bottleneck. Yeah? We need to eliminate the bottleneck in our operation. Consider load splitting of lab job. Often work best when there are large difference in job time. Theory of constraint, an approach to scheduling developed by Ellie Goldratt. This is about bottleneck operations, limited system output. Therefore, schedule bottleneck operation in a way that minimize their idle time. So we need to minimize the idle time for bottleneck. Drum, buffer, and load. Drum is the schedule, buffer potential constraint resource outside of the bottleneck, and drop represents synchronous sequence of operations to ensure effective use of bottleneck operation. Okay, there are two kinds of this output this process batch. Okay, this is a basic size for it, and then transfer batch. This is a process of basic slot that could be used during productions to facilitate utilization of bottleneck operation. Okay, improving bottleneck operations. We need to determine what is the content of operation. We need to identify what kind of the activity that can make the bottleneck operation. So we need to eliminate it. First, exploit the constraint, subordinate everything to the constraint, determine how to overcome, eliminate the constraint, and repeat the process for the next highest constraint. Okay, theory of constraints metric. Theory of constraints metric. The three important theory of constraint metric. First, throughput, the rate at which the system generates money through sales. The second is inventory. Inventory represents money tied up in goods and materials used in the process. Operating expense, all the money the system spent to convert inventory into output, including utilities, scrap, depreciation, and so forth. Service operation system, a problem. Service scheduling often presents challenges not found in manufacturing. These are primarily related to the inability to store or inventory service, the random nature of service requires. And then the service scheduling may involve scheduling for customer, workforce, and equipment. Scheduling service operations, scheduling customer demand management and appointment. It can be considered become two kind of the system: appointment system and reservation system. For appointment system, this is control the customer arrival for service. For reservation system, is estimate demand for service. Scheduling the workforce is the capacity management, cyclical scheduling. This is employees are assigned to work shift or time slot and have day off on repeating basis. Okay, cyclical scheduling is in many environments. The scheduling requirements are fairly similar. For example, like hospital, police, fire department, restaurant, and supermarket. This is rotating schedule. Set a scheduling horizon, identify the work pattern, develop basic employee schedule, and assign employees the schedule. Okay, actually, this is only the theory. Yeah, for the calculations, I will share to you through the link that explain to you how to calculate the scheduling in our in the scheduling material. And also, you can see our module. Yeah, and the module is I think this is quite clear how to calculate the scheduling in our module. If you have any question in the module, please inform me. Yeah? Thank you very much. Assalamualaikum. warahmatullahi wabarakatuh.